Hi everyone, my name is Asif Gill. I'm Associate Professor at the University of Technology, Sydney, and I'm also Director of the DGSAS Research and Innovation Lab at the School of Computer Science, University of Technology, Sydney. Welcome everyone to Information and Knowledge Engineering Conference 2021. In this paper presentation, I will talk about adaptive information architecture, and in particularly within that, I will look at that information elements, identification, and organization patterns for digital ecosystem. So welcome everyone. I will just start my presentation. Since the context of this paper is digital ecosystem, so first I introduce what is digital ecosystem. Digital ecosystem is a set of interacting actors. Those actors could be individuals or organizations, or could be devices or other non-human things as well. They interact with each other and they share information. And that's the whole promise and the definition of the digital ecosystem. You can see that here, the different actors involved, they can come from different organizations. They interact with each other via different interfaces, and during that interaction they actually use or consume or share a lot of data or information, and that we can call a value network. And the reason of that interaction is to achieve certain outcome. So that's the definition of digital ecosystem. There are different examples of digital ecosystems. There could be a digital automotive ecosystem, digital agriculture ecosystem. It could be digital banking ecosystem. It could be digital courier system, and so on. So there are many examples of a digital ecosystem. There are not only one kind of an ecosystem that exists. And in this particular presentation, I will talk about adaptive information architecture for the digital ecosystem, where the information flows beyond the boundary of a single actor or organization. Before I talk about information architecture, let's look at the holistic picture. In my current work, I have developed the digital ecosystem information framework. It has different knowledge areas, and one of the knowledge area is information strategy, architecture, and governance. And in this presentation, I will more focus on the information architecture concept. Information architecture is a part of a large adaptive enterprise architecture framework or capability. Here we can see that within the adaptive enterprise architecture, we have interaction layer, which is involved interaction between the humans, technology, facility, and environment. And further, each human layer has their own sub layers or subdomains or sub viewpoints. It could be a business viewpoint or a business architecture. In this presentation, we discussing the information architecture or a data architecture. Information architecture is independent of the technology, and when we link to the technology, it's more focused on the raw facts and other things which we call data managed by the different application platforms and infrastructure. And then the facility where this information and the data exist, and the environment which influences that, and the security of all the assets within the adaptive EA. In particular, this presentation, I will talk about information architecture, which deals with the structure, behavior, value proposition, purpose, and protection of the information. And in this presentation, more precisely, since adaptive information architecture is a very large topic, I will only focus on information identification and information organization patterns and challenges. The main challenge which is addressed by this presentation in this conference paper is that okay, we wanted to architect information for environment or information design for the digital ecosystem. But digital ecosystem has many actors, many organizations. They share or manage or consume information internally, but externally as well. So where to begin and how to identify those information elements in the digital ecosystem which we needed to configure or design or integrate or describe in our digital ecosystem context. So I will discuss two important things here in this paper presentation: how to identify the information and how to organize that information when designing digital ecosystem information architecture. In order to address the challenge of how to identify information, in this paper and presentation, I have identified information identification pattern. This pattern actually allows us to identify the information. For instance, information identification lens, which is proposed in this paper, comes from the theory of information triology, which focus on the digital ecosystem and their information exchanges. The focus is around three things. If we pay attention actors within the digital ecosystem and their interactions, and interaction involve those information. So if you look at this triangle, then we should be able to identify that information which is being shared or used or consumed by that particular digital ecosystem. So based on that theory, there are 9 generic elements, and we can use those generic elements to create information identification lens or pattern. So this information identification lens can help us to identify different type of generic elements which can be used to identify different specific elements for a specific type of digital ecosystem. This slide presents a case study of the application of the information identification lens or pattern. And this is a case study of a tree information management system, a system which requires to handle tree data or tree information across the country. And in order to manage that tree information and anything related to trees, we use that lens, information element identification lens, and identify the tree information elements for that particular system. So if we look at those 9 generic elements like organism, place, time, thing, event, mechanism, state, intuition, and consequence, we can see that using that. For example, organism, we identify that tree is a kind of a plant. So that's we identified. And then we identified also a tree manager as one of the individual insurers, builder. So you can see that all these kind of using this organism as a lens, we can identify all the organisms which are involved in that particular information management system for trees who interact with that with each other. And then those interaction happen at certain places. We need to identify those places. And then there's a date and time involved in that. Then there's the things. There could be a tree removal service. There's a damage assessment service. There's a work order. There's a payment. There's a material involved. There's a truck. There's a chipper. There's a crane. There's a stump grinder. You can see the different things these actors interact with as well when dealing with the trees. And then there's an event which impacted the trees as well, like the flood and tree falls and all these things. And then the mechanism, for example, when there's a tree fall or flood, this could be some kind of an incident, and that incident needs to be managed. So there's mechanism is all about those processes which are executed once the event is triggered. And in the end of that process, or during that process, there is some kind of intuitions. There could be happy or sadness or unhappy intuitions around that. Then there's initiated or plan, progress, paused or done state of those processes or those interactions. And in the end, what are the consequences are, what are the benefits, what are the outcome we achieve through those interactions. So that's where the consequences we need to capture, like the tree information management cost and benefit, insurance, and all these things. So we can see that here, these 9 elements can help us to identify tree elements for storing and managing within the digital ecosystem of the trees. So that's an example of one of the case studies. So now we'll look at the information organization pattern. Once we identify the information what the next step, how we organize into different kind of buckets. So this pattern is used or proposed in this paper for organizing the information once it's identified. So information organization lens has a couple of things. One is all the 9 top level elements, generic element, could be used as topics. Then each topic has element. Let's say organism has an element called individual, which could be resident. It could be an organization, which could be insurers. It could be a plant, which is a tree. So that's how organism could be a top level topic. Within that, you can have those elements relevant to those topics. So topic is a collection of elements. One topic can have many elements. Then we can have a core or foundational or specific supporting or enabling a topic. So we can have further categorization as well. But for here, for simplicity's purposes, we have organism can be have a sub-element or collection of elements, and those elements could be configured or could be arranged or belong to different subject areas. So an element could belong to a topic, and subject area can have elements which can come from different topics. So for example, subject areas insurance could have a resident and insurers and tree as elements, but it can also the same element can go to payment management as well, where the resident insurance and the tree insurance regarding payment is generated in the payment management category of the business. So subject area could be specific to a business or a context where these elements will be used. So that's how we could put it that way. Further, we can organize topic, element, and subject area sections further. These elements could be further organized as a taxonomy and ontology, and we can use information or knowledge graphs to do that. So element could be a vertex, and elements and their relationship could be picked up via edges of the graph. Graph has those edges and vertices, which are relationships and actual elements. Those information can be described in their properties. And then these relationship and elements could be some type or classification. So that's how we can organize the information as well. So once we identify the information, and then we can organize using topics, elements, or subject area, and then we can further organize them as a taxonomy and ontology using the knowledge graph or information graphs. This concludes my presentation for Information and Knowledge Engineering Conference. I'm happy to answer any question, can be contacted via email, which is listed here. The idea is that digital ecosystems are very complex environment involving a lot of organizations and individuals and other things which are interacting with each other. Important is that when we architect, especially information architecture, data architecture, is very complex to how to identify the information and how to organize that information for processing and protecting and using. And that was the main purpose of this paper, was to present these two patterns. One was to identify the information, and the second was to actually organize the information. Thank you very much. Happy to be contacted via email for any questions. And you can watch this video or repeat that video as you like. Thank you.